Welcome to this new podcast series brought to you by the Electrical Safety Network. I'm Dave Austin, and I'll be hosting the programmes along with Gary Gundry, technical author and trainer who brings insight from the contracting world and specialist knowledge from BS 7671, the regs, and on-site guidance. Today we investigate TEGG and how this technology is allowing us to carry out testing with no operational downtime. Our special guest, bringing his experience and knowledge of the TEGG process, is Andrew Livesey, MD of Lantei. Here's a taster of what you'll hear.
You can't just go into a hospital and turn off the main switch, and therefore you're restricted to the tests that you can do. So looking at a main section panel, for example, and applying TEGG to that, and maybe applying fixed wire testing to a distribution board where you've got full control, working together, you're getting a much more in-depth understanding of your installation.
This is using technology to identify potential risks. I suppose this is a service that you're trying to encourage businesses to invest in themselves. You're forecasting potential risk. This could affect their business, downtime, and I suppose ultimately could be a reputation.
An in-depth look at the TEGG process and applications over the next 30 minutes. To start, I'd like to welcome today's special guest, Andrew Livesey, MD of Lantei. Welcome, Andy.
Thank you, David.
TEGG. In a headline, Andy, what is TEGG?
Yeah, so TEGG's planned preventive maintenance in a nutshell. It's something that's not to replace processes that are in place that we're familiar with in the UK at the minute, but it's definitely something that can add a value. And that's what I believe as an electrician.
And Gary, from a contracting point of view, from a regs point of view, where does TEGG sit in the mix?
In the contracting world, we see TEGG and anything else like it as supplementing the minimum tests that are already in BS 7671. So it's added value, it would complement it, it would never replace it because they're essential as well, the tests that are in 7671. So this is something over and above, using technology, just going to another level.
So what are its core applications, Andy? I mean, this is not applicable for every installation, is it?
No, not at all. So it's more for items of equipment that you wouldn't look to switch off. So items that you might find in hospitals or data centres. It certainly isn't something that you would apply to a domestic house, say, or something that you would be able to have total control of. So it's more looking at things that can't be switched off and would cause real downtime, operational and costly effects if you were to isolate. It's all live working.
One of the big questions people often ask about TEGG is what does it stand for? And of course, it doesn't stand for anything, does it?
There's a couple of things that they've said. So we were told that it's Centre of Integrity, so TEGG with another G on the end, and then another guy's told us that it's the Electrical Good Guys. So that's
very good.
Which.
But that really smacks of its American roots, doesn't it? It comes from America, and it's a bit hypey and a bit gimmicky. Would you say?
I think when you look at the way it's marketed over there, or you're looking at the websites over there, it's totally different to our approach. It is how they carry out electrical works, and condition monitoring, etc. over there, and it's a lot more familiar over there. But from my perspective, the reason we've got involved in TEGG is because we're predominantly set up to do electrical testing, electrical inspection and testing, obviously filling out EICRs. And what we was finding when we was out on site is that certain buildings, it's very difficult to run a full range of tests on essential equipment. So for, again, using a hospital as an example, you can't just go into a hospital and turn off the main switch, and therefore you're restricted to the tests that you can do. So we believe by looking at a main section panel, for example, and applying TEGG to that, and maybe applying fixed wire testing to a distribution board where you've got full control, working together, you're getting a much more in-depth understanding of your installation.
So Gary, where does that sit in the requirements of the regs? I mean, that's an over and above, isn't it? You wouldn't be expected to do that.
Absolutely. This is an over and above requirement, but as Andrew's just explained there, you've got your operation, you've got downtime, you might be loss of income. So if something breaks down, it would be very hard to use the tests and test sequences that we've got in 7671 to establish that there's an arcing on a contact in a multi-case circuit breaker, or an isolator was overloaded. Perhaps you've got one of the phases is heavily overloaded. There's thermography, which I think your TEGG covers that. So it's X-ray vision into something that's not possible. But if live working is frowned upon, it's not eliminated. It is permitted, but you have to meet 3 requirements in Regulation 14. It's unreasonable for the person to turn it off, obviously, because it's a data centre, or a hospital, 24/7. Most of the tests that we can do in 7671 can be isolated. So a domestic property, you can turn it off. If you're working in a commercial building, you could work out of hours. But some procedures like water companies, hospitals and the like, just have to keep going 24/7.
And let's look at the tests that we're talking about, Andy. So it's thermography has been mentioned. There's sonic tests as well. Just outline some of those tests and the kit you use.
We work to BS 7671 in America. They work off to the NFP. The NFP, we sort of build our boundaries, arc flash boundaries, using the guidelines in the NFP, and then the processes for visual inspection, etc., are all taken from the British standards. So if you imagine you're in a switch room, the NFP will dictate the arc flash equipment that you'll wear. So the first step is the ultrasound. Ultrasound is done with all of your panel covers in place. You run the ultrasound gun over all the gaps, crevices, joints and things like that of a panel. That can detect, obviously, sounds the human can't. So if there is a loose connection, it would detect that. And if you know that there's a loose connection behind that panel, therefore you don't move forward with the removal, because ultimately if you know that there's a noise and there's a potential for a loose connection, it would not be safe to withdraw. You're then going back to the customer to say, here's the sound clip, listen to it, this is what it means, and basically there's further investigation required. Now, that isn't necessarily something that needs to be done immediately. Again, it's about planning it in. Now, it is rare that these connections are loose on such large pieces of kit. So generally, you can move forward at that point, providing there's no noise. So you would withdraw the cover. Again, working within the arc flash boundary, our engineer would be wearing the suitable arc flash equipment. And then you'd run a thermography caption. So you'd take the thermal camera, run it over all the contacts, everything that's behind that panel cover. What thermography is good at doing is seeing things that the human eye can't. So as Gary mentioned, sort of phase imbalance, loose terminations, degradation of contact within a piece of kit. So thermal caption might detect something, and then you're then moving into that point. Instead of just saying, right, there's an issue, thermal caption has identified that issue, you can then start on your mains analysis. So with your thermal imaging and your mains analysis and the two combined, you can start to diagnose what the issue is. So if we talk about an MCCB, for example, you've got 3 poles, like a gate being open or closed. So let's hypothetically say it's in the on position, so the gate's closed. With a millivolt test, you're able to test across to see if there's any millivolt drop across the phases. There's tolerance levels that are set in the NFP, and if you see over a 50% difference between the poles, you know that the scope and potential for degradation on that. So again, if your thermal camera's detected a heat spot across a pole, you do a millivolt drop test, it's telling you that there's degradation on that pole. And again, it's about planning that in then. So going back to the customer and saying, there's something here that you need to look at because that's outside the parameters. Let's roll in the generator. Let's not just let this break. Let's order this in.
So you'd have something ready then for when the installation's closed down, you can do the work quicker.
So part of the process is asset management. So on the side of an MCCB, it'll have nameplate data. So if you just took a picture of it, you might buy something that's got incorrect dimensions or different types of fitting within a panel, but with the nameplate data for Schneider, say, you can just get that ordered in, and it's basically when you remove it, you know that you're putting something in that is exact like for like, rather than just taking a caption and looking off a caption.
A lot to unpack there, Gary. So how does that sound to you?
Sounds like somebody needs to be really skilled at what they're doing here. Based on what we've talked about, this is keeping the operation running. This is forecasting downtime. I wouldn't want to lose half a section of the building, because, time is money. You might be manufacturing, or you've got lives at risk here. When you mention this millivolt, then, is this from the incoming poles and the outgoing poles?
Yeah.
Yeah. So I can see that, this is using technology to identify potential risks. I suppose this is a service that you're trying to encourage businesses to sort of invest in themselves. You're forecasting potential risk. This could affect their business, downtime, and I suppose ultimately could be a reputation. If you can't deliver the goods at a certain time, it's like, I'm sorry, we're going somewhere else.
Yeah.
Do you find that it's a hard sell when you're talking to customers?
Yeah, I mean, everything's driven through insurance, isn't it, in the UK? And everybody's aware of EICRs being the way to satisfy the insurance company. But again, we're kind of looking at this from a technical point of view to say, well, as a skilled electrician and understanding the principles, I really like this. And the way I see it is it's kind of like a double-edged sword. You're still following, the visual inspection. You're up close and personal to the kit, and, you're looking at it from a visual inspection point of view, which is what you would do anyway on an electrical test. But ultimately on a condition report where you can't take the panel covers off because it's not safe to do so, whereas you're in the arc flash equipment, you can see you're running the tests. I just believe it dovetails very well, with the condition reporting.
That's a really good point. And I think that when contractors work with clients, they have an aspiration that we want everything checked. But on the day that they may send an operative, the client will say, oh, you can't turn that off. And then you have to put limb, don't you? It's limited, right? So, if you have lots of limbs, this report is becoming less and less meaningful. Yeah. Therefore, as under the Reg 4.2, the duty holder has a responsibility to maintain all of his or her system, and they're not doing that. So you've got the EICR, which gives you this projected of a pass, or maybe, but only for a proportion of it. So what you're able to do, I'm establishing, is that you're taking everything that offers in BS 7671, and can you imagine a moulded K circuit breaker, MCCB, fails, it's like, why didn't you pick that up? That will never pick up. So no. You're using technology and a huge amount of knowledge and experience to impart onto the client to say, this is your business and we can resolve these issues. So I can see that there's a courses for courses here. So domestic, small commercial, maybe light commercial, it would be favourable to do the traditional testing, but you're going to another level, which is sounding pretty good actually.
Yeah, I think just a point to make on that, so if you've got a large installation, the first few pages of your report after page 1 to 4, they are all the big switch gear. So it's the beginning of the installation, the origin of the installation. So potentially, if you was to do a hospital, the first quarter of the report could potentially be with no isolations and purely visual inspection and live test only where accessible. So I have heard the phrase, it's not worth the paper it's written on, but sometimes you've got your hands tied, haven't you, because you're governed by what you are physically allowed to do on that site within the remit of the customer saying that can't be switched off.
Yes, I mean, if anybody knows me, I've done a lot of training sessions up and down the country, and one of the things that electricians ask me is that I've been told to do this test, this building in a day. That's not their concern. It's the client. It's about their responsibility under Reg 4.2 of the electricity at work regulations to maintain that. If that means you've got to spend a week there, but you're only giving the client 1 day's work, you would be let off. But they feel they either, sadly, make up the figures to justify their work, or they're working there till midnight, shaking in the boots, thinking, this is all going to come back on me. The responsibility to do all this testing is the duty holder. So your clients have got to maintain their systems. They're maintaining it in a smaller way, but investing in your TEGG process is investing in their business. They're complying with the law, but they're trying to protect their reputation and business and financial recompense.
It's a little bit like the way medical science is going, though, isn't it? That now it is possible to see the future. What impact does that have on the duty holder now that they know they could actually do that? If they don't do that, are they exercising their duty fully? Is this posing a problem, in fact, for people who have to maintain systems, knowing there's an opportunity to do it more thoroughly than they are, but they have to commit to TEGG?
Okay, I've never heard that one, Dave. That's pretty good thought process there. I'm digesting that now to see it from 2 points. I'm falling on electricity work regs, which is thou shalt maintain the system for safety, okay? But to protect one's business and financial income and justify the shareholders and all people's lives is another level. That wouldn't fall under the electricity work regulations. So it's almost like there is tools or technology that gives you more insight into your operating side of things to make someone make an executive decision to spend money, shut down the business and say, I know this is going to be an inconvenience to us, but we can manage this. So you can bring in a generator or something like that, and therefore you can put things on. So it's almost like a parallel exercise, and the MCCB gets changed and it all switches over nicely and everybody carries on. I'm not sure that fits in with EWR to say that you didn't maintain it. Well, you are maintaining it, but you just lost 2 weeks' work waiting for the kit to arrive.
Have you got examples, Andy, where somebody has discovered a forthcoming issue and acted in time?
Yeah, I mean, it's quite frequent that we find issues with millivolt drop, withdrawing the covers, doing the thermography and spotting a rising temperature across the casing rather than the contact across the casing. And you can see it's degrading over the time.
When I did a one-day course with a brand name thermographer, we were mentioning figures of like 60 degrees as a spot temperature. And I said, I'm not worried about that. I can see electrical contractors going, that's below 70, so it's not a risk. But the gentleman that did the training course said, we take two temperatures, one at the point of determination and one a bit back, and that gives you the indication that there's a transference of temperature and there's a difference, and it's easier to work out and forecast that there's a loose connection.
Yeah, it's all comparative.
Or over tightened. I wasn't aware of that. So yes, they can move, can't they?
If you're looking at that one snapshot and you can see that one cable's operating at a certain temperature, and the same cable, if it's an armoured cable, if L3 is operating at a much higher temperature than L1, is that a loading issue? Is that a loose termination, or is it degradation of equipment?
Yeah, but you're building a picture up, aren't you?
Yeah.
You're using the thermography and the current testing to sort of to confirm your thought process.
So that's the thing. I think we've always sort of used thermography in the past, to supplement some of the fixed wire testing, because again, it's if you're limited to what you can do in a panel, let's use thermography where we can. But now, we feel we're a lot better placed to sort of diagnose the problem rather than just say there's a rising temperature, here's your report. It's sort of there's a rising temperature and this is all the rest of the readings that we've been able to pull together.
Is this something that also allows some comparative analysis? So if you've done an installation, then another year you go back, can you compare those two and see degradation?
The software that we've purchased is got all the logic in the background, so we key in the readings and the temperatures that we find, and that will ask questions, flag things for us. But ultimately, you're creating a job if you're going every year to look at this one piece of kit. So let's say you're in a manufacturing plant and there's a conveyor that's making you an absolute fortune, and it's a case of that can't ever be switched off, and we're going to subject this to TEGG on a yearly basis. You've got all that data there to be able to analyse, and what it does, the software, is that when you're plugging in your information in the following year, again, it's telling you the comparative, so you're looking at it yourself, but the software's also telling you this piece of kit, L3, is changing differently, or it's rising in temperature more so than L1 and L2.
Yeah, that's encouraging to know, because, in the world of EICRs, as people call them, the process is, job's done, it's written, it's signed off, and it's put in a filing cabinet and forgotten about. But one of the benefits that should be done is to look at that data and compare it with the last set of results to say, is this degrading? I think very few do that, because it's seen as a sort of tick box exercise, job's done, let's move on, it passed. But I was talking to cable manufacturers and also instrument manufacturers, and amazingly, this gentleman said to me, based on technology, he said, I can forecast that a cable will fail in 7 years, or 4, or 2. And it's like, now this was a game changer, because I don't think most of the industry knows it. So you're using your technology. If you saw a particular value and you said, it's okay at the moment, and then next year you come back and take another figure and it's less, okay, it could be 1,000, like meg ohms for insulation resistance. You say, it's not a problem, that's way above the minimum requirement in 7671. Come back another year and it's gone down again. You then got to plot a graph, and you can just say every year this will break down. And slowly, and within 4 or 5 or 7 years or whatever it is, that cable needs replacing. Now, why aren't we using that? It's people's minds just need to be opened up about this. It's a case of, it's past, yes, but as a business, you want to forecast this. And I think downtime, income protection and reputation protection would actually wake up people to think that I need to be aware of this, because if you miss it or don't act upon it, it could cost them their job, I suppose, or people's lives, or it could catch fire.
It sounds like Gary Gundry is fairly convinced that TEGG's a pretty viable thing.
Well, technology, if it's used properly, is always a good thing in my mind. I think that some electricians would probably be nervous of working in close proximity. You mentioned this PPE. I mean, I've seen some horrible videos with this arc things. I mean, this would save someone's life, would it? This kit is that good?
Yeah. So it's rated at a specific calorie and that means that you wouldn't catch fire.
No, I did watch the videos.
Reassuring.
Yeah, I mean, yes, you're engulfed in flames, but I mean, I try and explain to people, and they don't appreciate the level of fault current that is generated, and the arc. They call it arc flash, and there's experts up and down this country that are better at it than me. But just to get that message across, you're wearing the right PPE. Do you have to wear several layers?
Three layers?
Yeah. So you got the T-shirt, the pants, the overall.
T-shirt and pants.
Yeah, so it's the arc flash T-shirt and pants, and then the overalls over the top of that. And it's...
Is that similar to what would be used by HV engineers?
Yes, yeah.
So it's that level of protection you're looking at.
Absolutely, yeah.
Amazing.
Yeah, that is good. I was going to say, and reassuring for the operative, because at the end of the day, no one sets out in the morning to have an accident, but things do go wrong.
Yeah, I think the other thing as well is that as you're set up in the switch room, so obviously two people working, one person on the laptop keying in the information as the other person does the measurements, and what the software tells you is when you can start to remove, clothing, or when you need to put the clothing on. There's it's like a trigger point. So for every step that you do, it's saying you now need to do this, you now need to do that. So obviously very sort of health and safety conscious.
That's what I was going to ask you about. That is because in the UK and other places in the world, we follow the requirements in 7671, but there's no method statements. These contractors have to write their own procedures, and there's HSG 85, which is safe working practices and things like that, to sort of follow flow charts. Is it the NFP?
Yeah.
NFPA 70. There are American regulations. So some might say that that's not the UK. How do we know? Are they better? Could they hold up in a court of law? You're following a different set of regulations that we have. I don't think we even have that capacity. So it's almost like you're using something ahead of its time.
Yeah.
In this country.
Yeah, I just feel like there's a blend of the two. Everything other than, physically removing the covers and stuff, we're working to BS 7671, but the building of the arc flash boundary, what parameters the millivolt drop test should work to. I mean, an MCCB that's installed in America is still coming off the same plant, so there's no real difference to that.
So you're following set requirements and procedures that have been tried and tested. One of my colleagues, he works for a distribution network operator, and his opening take on a training day is, "Good morning, ladies and gentlemen. What you're about to hear today is based on 100 years of accidents." So basically, what we're following today is not because we want it. It's things have gone wrong, so we put policy and procedures in place to help save people's lives.
Yeah.
So you're following that's good.
So the ultrasound's very important, because any detection of anything, you're stepping away.
So is it visual and audible?
The trained engineer with the ultrasound gun will hear a noise, and it will produce a sound clip. It plugs into the computer, and then you can observe the sine wave of the sound clip, and it's clear what a loose connection is.
So there are characteristics in the site, that can differentiate a loose connection.
Very much like AFDD, so using that comparative process to look at a set waveform. Yeah.
That's it. Yeah. So it's arc flash. If there's when you download the clip, you're watching the sine wave. So there's the noise, and then there's the sine wave.
This is very similar to the way sonar detectors work in submarines. The guys with the headphones on, listening to sonar blips, they can recognise the size of a ship.
Yeah, but if there's any noise, the cover's staying on. It's as simple as that. Let's isolate this. We know that the submarine's been isolated at a convenient time to the customer. You're still going to use your ultrasound to make sure that there's no feed coming from elsewhere, or you've safely isolated it, and then locking off the device, and then it's straight into the regs book, isn't it?
Yep.
There wouldn't be a requirement necessarily for the rest.
So this is where the layer again sits above the regs.
It does. I mean, when the IET or the ECA call me to help out on their technical helpline, occasionally some contractors will phone up and they ask what is the minimum. You would hope that over time they know what the minimum is now, but clients are asking for less and more, and I think one contractor, he was under the impression that the insurance company was driving this, basically, as you alluded to earlier, that they wanted the test done every 2 years. They wanted their building electrically inspected and tested every 2 years. He said, "I thought it was 3. Could I go to 5? But because of the requirement from the insurance company, they were asking for that reassurance. And I said, "And what did you find from last time then?" He said, "I didn't find anything." "And what about the time before?" He said, "Nothing." He said, "Honestly, this is like an operating theatre. This thing is super clean." So I said, "Well, ask them to go to 3, or extend it. And if they don't, you can always go to another insurance provider. And ultimately, if you had evidence Initially, it could have been photographs, you could have done thermography, and now with TEGG, you could provide them a whole suite. So this could help someone's business, I suppose.
Yeah, absolutely.
Save on insurance.
There's one of our new customers who found that we're doing TEGG now in the north of England, and we've engaged with them, and their insurance company pays for TEGG because of the potential loss of earnings for downtime. They're saying, we want you to have TEGG.
So if you looked ahead over the next 5 years, would you expect that TEGG would be a standard feature of planned maintenance?
It's a difficult one, really, because from my perspective as a qualified electrician, gone on to do engineering at university, if I'm trained and qualified and I believe that there's value in it, then I'm sure other people think that. Engineers working in big factories, managing big electrical installations, if they understand and they're aware of the processes, then I believe that they'll see that there's a lot of value in it, and that's where the potential is. So, the country a better,
safer place.
Potentially, yeah, and less frantic with 3 o'clock in the morning, conveyor belts breaking down and things like that. Hopefully, it'll save a lot of stress for people, but who knows?
And Gary, what about its inclusion in the regs? Do you see a future for it being accepted in maybe to Part 6?
Good question. I think that there's always a point where people will catch up with new technology, because this is definitely new and pushing the boundaries. BS 7671 has the minimum requirements. There's a suite of guidance notes that the IET produce, and guidance note 3 covers inspection and testing. And I know that thermography is included in there. One of my colleagues in the industry, he managed to get that in there. So there's recognition and appreciation of it. It doesn't change anything. It supplements it as added value, supplements the whole thing. Some of the ultrasonic side of things, I think it's just specialised skill. I don't see that going into the requirements, but I do know that the committee that is looking at inspection and testing would like to dissect it into 2, new work and periodic. So I think that would be like the requirements, and anything else would be guidance to help business. So that's where it would sit. That's it. That's why I see it in my opinion.
That's typical regs answer, thanks, Gary.
That's how we operate on the committee.
Thank you very much to Gary Gundry for his insight, and also to Andrew Livesey from Lantei for terrific information and experience of TEGG. So what do you think? Have we inspired an interest in TEGG as part of planned programme maintenance for your organisation? Well, whatever your response, I hope you found this podcast informative and useful. Listen out for further Electrical Safety Network podcasts. I'm Dave Austin. Thank you for listening.